So the focus of the Tech Hour this week is user help and user documentation. Of course, when tech was developed, we didn't have the internet. We had email just about, but not many people. We didn't have the internet. We didn't have web browsers. And all the documentation was written documentation, and tech was a language for writing books. And that was in the 80s. And such a lot has changed now. And the web browser is much more capable, the networks are much more capable, computers are much more capable. What we used to regard as a preview is sometimes the only document, is sometimes something that's never printed. Certainly I get these bills that are PDFs and I never print them, even though technically they're previews of something I can print. Now, I'm gonna start by talking about users, and I sort of want the focus, I want this to be driven by the user experience. And I'm a bit biased in my user experience against the old people who've been doing these things a long time and in favor of the people for whom the mathematics and tech are both new. So when I started learning tech, I already understood all the mathematics in the tech book, or at least the mathematical side of it, or at least if I didn't understand it, I could at least read it and it's familiar to me. And I felt very, very proud that the final piece of the textbook, Advanced Mathematics, was actually a piece of mathematics that I understood because I happened to do a PhD in the appropriate area of mathematics. But our focus now in this Tech Hour, I hope, is on people who are new to the quadratic formula and new to tech. That's the sort of lowest level I think we're probably dealing with. And then going through to somebody who was writing an undergraduate term paper or something like that. So I'm going to start off with some user tasks, some tasks that the user might want to do. And in this, I'm reminded of the brilliant phrase, people don't want to use your software, they want to have used your software. So they're using your software for a purpose and they want to get it done. A car is not something to drive. A car is something that gets you somewhere else, that gets you where you want to be. So here are 3 writing tasks. The first is to type a paragraph of text that contains mathematics. Fairly simple mathematics, but mathematics all the same. So that's a sort of simple exercise, and somebody could get a feeling of accomplishment for doing that, and it may be that they need to do it for some reason. The second thing is to type up, for example, a formal proposition. So you have to know much more about the structure of your document to do that. And a third task would be to type up a simple table. Now, traditionally, we learn to read before we learn to write. In fact, we learn to talk first. But, so we can have all of the above, but reading and understanding examples. So we have an example of a formal proposition, and we want to be able to see the text source and see the printed output and understand all the parts. So we want the system to be able to we want the system to allow us to select a part of the input and explain it to us in some sense, and similarly to select a part of the output and see where it comes from an input. That's a sort of inverse search sort of thing. So here's some more examples. We can view them as both reading and writing. When we've got a template, when we're using a template, what we do is we read the template and understand the template to a sufficient degree, and then we write into the template. So reading and writing are very close to each other. So we can have aligned equations and including a figure, and more complicated, more advanced math from a typographic point of view. So that would be things such as cases and what are called commutative diagrams, matrices, and complex formulas such as formulas where you have an expression that is larger than the measure. I try to avoid those in my writing if I can. Then users are also faced with tasks of discovery. So knowing what symbol to use, knowing the LaTeX name for it, and providing suitable restricted vocabularies for any given area, or at least for some given area. So certain symbols are only used in certain areas of mathematics, and they're used for particular purposes. So the value of a restricted vocabulary is that it makes it easier to choose, to find what it is you're looking for. And a good way to get a restricted vocabulary is to take papers or other documents in the field and see what symbols they use. And advanced textbooks, or all books, I hope, have an index of symbols in them saying these are the symbols, these are where they appear, and this is what they're used for. It's a great way of getting an overview of the system. So these are some user tasks that I see somebody wanting to do. They don't want to learn LaTeX, they want to perform some task. And to perform the task, they'll have to learn LaTeX or some other system. So that's how it goes with users. I've not been able to do as much research on this topic as I wanted to before this meeting. So I don't have a sound view, I just have a prejudiced view as to what there is available for users in these various topics. But we can at least think, well, what would be ideal for the user, or what would be best from our experience.